All right. This is called More on Classes and Objects. It doesn't have a section number. This is just some random things I wanted to reinforce. ToString method always has this exact header, public string ToString. And I've already told you this and you've seen it, I think, but the ToString method is called automatically when you print an object. And if you get something like this output, student at, weird number letter combo thing, that means you don't have a ToString. And sometimes I've seen people spell ToString without the capital S. That would make it not work, or make the T capital, or, it really matters. It has to say public string ToString. Anyway, no big deal. If you want it to have a ToString, then that's how you have to do it. I want you, on the computer or on a piece of paper, I want you to write a possible ToString method for this class right now. So you could open a Google Doc. You could get out a piece of paper.
I'll try to Google Doc. If it wants to load, then there we go.
I want you to write a ToString for this class.
I have a string name?
Yeah, or open up text edit. Click on the Windows thing and type text. Notepad. You could open that up.
Google Doc.
Yeah, we know that.
We've got two variables: the name of the hamster and the weight in kilograms.
How do you
Just
do
grams.
grams?
Yeah.
In metric tons.
Capybara is a relative of the hamster, and it is bigger than most of many dogs. So here you go, public string ToString. That's how you start it.
Wait, what is it?
No, stop automatically capitalizing.
Oh yeah, that's the problem with the Google Doc.
That's why I'm doing Notepad.
The Notepad would avoid the
My
auto
hamster's name is gonna be what's the hamster's name be? I'm naming my hamster Gregory.
Yeah, so you don't need to know the name. You have a variable called name. So you can still choose a name for your hamster, but it shouldn't be in your code.
What?
Public string ToString, and then return, and then some stuff. No. This is a class. I gave you this class. We're just writing the ToString. And it says constructor and methods not shown. I'm sure there'd be a method called squeak. You call it, and the little hamster goes. Couldn't get any higher than that. All right. I'm going to show you mine.
Oh, I was so close.
Public string ToString, return name plus weight grams. I mean, you didn't have to do it that way, but because I didn't tell you what it's supposed to look like, but I wanted, we want to know about the hamster. What's his name? How much it weighs?
He weighs 10,000 kilos.
It's a big hamster. What I was looking for is that you would write a ToString that at least included both variables,
There we are.
name and weight.
Wait, why is there a quotation?
If the quotations, my quotations are around the parentheses.
Oh,
I can add a space here and a space there and a space there and a space there to make it a little clearer. All right, so that's just a little ToString practice. Second, using accessor and mutator methods. So we learned last time, accessor methods, if they exist, are methods that give you access to, they tell you what certain variables are that are otherwise private. Mutator methods let us change those things. Today I'm going to show you how to use the accessor methods to compare two objects. So let's say I have a student class and I have two student objects that I create right here, student S and student T, and they are the same, right? Now we can write code that'll check if they're the same. And we would consider them the same if they had the same name and they had the same GPA. So this is one way we could do it. So if the student class had a get name and a get GPA method, I could write in another class if s.getName equals t.getName and s.gpa equal t.getGPA, then they're a duplicate. Otherwise, they're not duplicate. Questions? Yes.
So if there was more than two students, could you take that code right into like a for loop or something that could have it check every single student?
Oh yeah. And we'll be doing that in a month. But this would be in the main method of another class, not in the student class. But you see how we could we use dot equals when it's strings. The name is a string, so we're comparing two names, and then we're using double equals when we're comparing two double variables. Okay, we have another way to do it. We could write a method inside the student class that checks the internal variables to see if they're duplicates. So if we're inside the class, you don't have to call the methods. We can actually just use the variables. Check this out. You could write public Boolean is duplicate. I put a number 2 there just to make it separate from the first one. Student other. So you have like student S and you go S dot is duplicate to parentheses T. And then because it's inside the student class, the code can just access the variables like this. Name dot equals other name and GPA equal other GPA. Then they're duplicates. Otherwise, they're not. Yeah.
That's just like a method lets you check it instead of writing.
Pardon?
So you wrote a method.
I wrote a method, and then it put it in the student class, and then this one doesn't have to access the accessor and mutator methods. It can. We can inside the class also use the methods. So check it out. You just call getName. If getName dot equals other dot getName and get GPA, that you can just call the method like this without an object when you're inside of the class. Oh, it's so funny. I don't have this anymore. So my REPL account, they were going to start charging me, so I deleted everything from it. I deleted my whole account, and then I made a new account, and I had all the space again. They don't make it easy to delete. Like I would have been like, oh, I'll delete everything older than a year, but it was one at a time, and I probably had 10,000 REPLs. I'm like, I'm not going to do it. So some things I lost in the process. Okay, we're going to practice doing the bouquet class. So I'll pause the video. All right, so we're back from our little break. And we're going to talk about section 5.7, which is static variables and methods. This is important. I'd love to see you all looking here. Get your hands off the mice, stop coding, look up here. We've seen the word static here and there, and today I'm going to explain it. The keyword static implies that a method or a variable belongs to the class as a whole rather than to a specific object instance. So if a static variable belongs to the class, if I had a static flavor variable in a pie class, all the pies that you ever made would be the same flavor. You couldn't make a pecan pie and an apple pie because if the variable called flavor was static, it would be, you set it in one place and all pies that you may have created all become that flavor. So when would this be useful? I'll show you in a minute. It's useful if you want to have each class have their own unique identification number, like a student ID number or a social security number or something. Or if you want to have, if you're doing commerce and you want everybody to have access to the current tax rate, That would be a variable that all the objects have inside of them. I'll show you. So if you want to make a unique ID for every object that you create, so here's a book, and we're giving the book a title and an ID number. You might think, well, if all the objects share the same variable, how can I make a unique ID number? Well, get this. You have all the objects share a variable called next ID. And then each object has another variable, which is that object's ID that's not static. So check it out. I've got private static int next ID equals 1001. That's right at the top of the class. So when I create my first book, it comes in here. Next ID is 1001, but we also have private int ID and private string title. So when we create a book, check it out. The title gets passed on. It gets the next ID and stores it in ID, and then it adds 1 to the next ID variable. So the one that's available to everybody went up by 1. So if I create another book, it grabs that next ID, adds 1 to it. Every time you create a book, you get another ID number. So they will all have different ID numbers. You already have access to this in terms of writing it down. Because it's the slide decks was with the book K class. So questions on what is showing here? August.
So that static int is being, in this example, everything is, you can change the next ID.
Any one of the book objects could change the next ID.
Only thing that can change the next ID.
That's yeah. Other classes can't change it. Nobody else could go in and go, I'm going to change the next ID to 2000. But when you create a book, this code just increments it by 1. I mean, first takes it because it's called next ID, not last ID, and then it increments it by 1 after using it, so that it's ready to go for the next book. So here's a common mistake. So that's that same class, but I added a toString. Notice this toString down here uses ID, not next ID. If you used next ID down in the toString, then all the books would get, like if you made 5 books, they'd all say their ID was the same, and it was 1005, because next ID is the next ID, not the idea of any particular book. So first book has an ID of 1001, second book 1002, and so on. And then this little toString returns the ID number and the title. And again, notice I'm using ID, not next ID. Next ID is the one all the different objects have access to, and they're only using it when they get created, so they can have a unique ID number. So here's specific example. If I ran this code somewhere else, book 1 is called Unforgettable. Book 2 is called The Amnesiac Diaries. I'm so funny. And then I printed them. This is what would come out of it. And in fact, for the other classes we're doing today, I'm going to ask you to make like multiple copies, multiple objects, and then print them all. So we make sure that they all have different IDs. Because if you do it wrong, they all have the same ID. Here's another example with a ticket class. This one I said private static int next num equals 1999, and there's a private int ticket. When you make a ticket, it adds 1 to the next num and then stores it in the ticket variable. So here I create 4 tickets, A, B, C, and D, and I print out D and then A, and this is what I get. Because A was 2000, 2001, 2002, 2003, and then I printed D, I got 2003, and I printed A again, and I got 2000. If we just use the static variable, I said things would be funky. Check it out. We have private static int next num. Every time you make a ticket, it changes the next num. But when you printed them, they'd all be 2003. Like if you don't have a separate place to store the one for each object, then they all have the same number. That whole idea becomes useless. Now we're going to talk briefly about static methods. Static methods belong to the class as a whole and are not allowed to change or access private variables. And mostly this is something we're not going to have to worry about. I will not test you on it, but I guess I have an example on the next slide. If I try to compile this thing, we get an error. So here's public static void set vals, and it tries to set the variables to this number, and it says you can't access var A and var B from a static method. So when do we see this? Remember, in all of our code, we have this class main in REPL, and then the next line is public static void string, a main string. That's a static method in the main class, and that's the one that runs whenever we run our code. So, we never have run into this issue of not being able to change variables because we're never creating variables up there that are in the main class. Anyway, this method, you won't in general be putting static in your methods. And I said mostly you're going to see static show up like this: public static void main string args. So that's Java looks for that line in particular when it wants to run. When you tell it to run code, it looks for that line. And you could put that line in any class actually. So you could write a student class and put that line at the top, and then when you run it, it would try to run the student class. It'd be kind of weird to do that though. And I think this is, if not my last slide, almost my last slide. I want to back up and give you the big picture for method headers. Method headers have 5 parts. There's the access level. That's public or private. I'm sorry, this is blocking one of my examples. I'll move it right here. So see where it says public string, toString, public void, set GPA. You could also have a private method, private static void, change next ID. They have an ownership, whether or not the qualifier static is included. And it's usually we just leave it off. They have a return type. That's either string, int, Boolean, or it could be void. If it's void, then you don't have a return type. You don't have a return call. And then we have what they call an identifier. That's the name of the method. In this case, toString, set GPA, change next ID. And then they have a parameter list. So that's in parentheses, or they have empty parentheses. And remember, the parameter list is part of the signature of the method. The signature is all these things put together. This slide will be helpful down the line. All right, so now we're going to write 2 new classes that use static variables. The first one, I'm giving you a student class, and I'm just asking you to add a student ID to it. So that way we didn't have to all rewrite a student class. I'm giving you the base class, and you just have to add the code to give it an ID. And then the voter class is fun. You're going to write a voter, a class that would keep track of a voter. And of course, if you need help with warm-up or bouquet, I can help you with that. So I'm going to stop the recording.